Bode plot. How to sketch Bode plot for this problem? So first we see sketch Bode plot for the following transfer function and determine the system gain k for the gain crossover frequency to be 5 radians per second. That is the first step. So we need to determine k value for the gain crossover frequency of 5 radians per second. Okay. So first, while starting the problem, we have to assign k equal to 1, and then k equal to 1 here then is given, and then put s equal to j omega. Okay. So you are replacing s equal to j omega and k equal to 1. So this equation becomes g of j omega equal to j omega the whole square divided by 1 plus 0.2 j omega and 1 plus 0.02 j omega. Okay, then we need to find out the corner frequencies. Corner frequency is nothing but wherever we get 1 plus st terms, we have to find out the corner frequency. Here you can see here it is 1 plus st term, and here also 1 plus st term. These terms we are called as first order terms. So for the first order terms, we need to find out the corner frequencies, and for the second order terms also we need to find out the corner frequency, but here we have only the first order terms. So first corner frequency, so this is 1 plus st, t is 0.2, here 1 plus st is t is 0.02. So we can take anything. 1 by 0.2 is 5 and 1 by 0.02 is 50. Which is the lowest one we should consider as lowest corner frequency, that is your first corner frequency. So omega c1 should be 5 and omega c2 should be 50. Okay. After assigning the corner frequencies, we must assign a lower corner frequency and higher cutoff frequency. Lower cutoff and higher cutoff. Lower cutoff should be less than omega c1 and higher cutoff should be greater than omega c2. So we should assign that. So omega L should be less than 0.5, so it should be 0.5, and omega H should be greater than 50, so omega H 100 radian per second. Okay. So this is we can also assume instead of 0.5 you can assume 1 also. Okay, below 5 you can assume any value, but better to assume 0.5. 0.1 also you can assume. Okay, and then more than 50, that is 100 radians we have assigned. Since the graph, while plotting graph only, you will be able to know 50 and 100 will be having small gap only. Okay, so so that to get a graph, neat graph, and to find out the better solution, we are going for 50, 100 omega h, not 60 or 70. Okay, so always choose omega greater than omega c2, omega h value should be there. 50 means take 100. Okay, so this is the lower frequency and higher cutoff frequency. And then this is a slope table. The slope table is going to tell you how the graph will be, whether it is going to slope is downwards or upwards. Okay, so here you can see the problem. This is j omega the whole square, and then 1 by 1 plus 0.2 j omega and 1 by 1 plus 0.02 omega. So we have 3 terms. So please write the 3 terms. This is the numerator, so j omega the whole square, and these two are denominators, so 1 by 1 plus j 0.2 omega and 1 by 1 plus j 0.02 omega. So we have written all the 3 terms, and this 2 terms will be having the corner frequency, and this won't be having. This is a we'll be calling this as a derivative term. Okay, s squared. S square will be calling as a derivative term. If it is 1 by s square means we'll be calling as integral term. So it is j omega the squared. So it won't be having corner frequency, so dash. But j omega square for 1s, the slope will be plus 20. It is j omega the whole square, so plus 40 slope is. Okay. Then for 1 by 1 plus 0.2 j omega, so here we have 1s. Okay, that is j omega is nothing but s. Okay, so we have 1 j omega in the downwards, so we'll be getting minus 20 slope. Same way for this also, this is minus 20 slope. Okay, here also this is minus 20. Okay, so both is minus 20, and omega c1, this is corner frequency is 5, and here the corner frequency is 50. Both slope is minus 20 since both are in the denominator. Now the change in slope we have to find out. Plus 40 minus 20 gives you 40 minus 20. We have to add these two. We'll be getting plus 20. Okay. Then 20 minus 20 will be getting 0. Okay. So this is the change in slope. Okay. So after finding the change in slope, we are going for the calculation of magnitude, that is A calculation. Okay, so magnitude is nothing but for omega L, omega C1, omega C2 and omega H for all the corner frequency and lower cutoff and higher cutoff frequency. For all the frequencies we need to find out the gain value. Okay, for omega equal to omega L, the gain calculation is 20 log of the independent term. Okay, in this problem the independent term is the derivative term or constant term or integral term. Okay, here the derivative term we are having, that is j omega squared. So this term should be here. Okay, we should not take the first order terms or second order terms. We should take only the integral term or derivative term or constant. Okay, so here we have the derivative term j omega the whole square. So omega equal to omega L equal to A equal to 20 log of j omega the whole square. We are taking only the magnitude, so j will go off, only omega squared. Okay, so like this. Okay, so omega equal to omega L. Omega L we have selected as 0.5. So 20 log of 0.5 square is minus 20 decibels. Okay, so we found one magnitude. Okay, for omega equal to omega L, the magnitude is minus 12 decibel. Okay, then after finding this, omega equal to omega C1, your A is 20 log of same formula for our first two frequencies, so omega L and omega C1, the same formula, 20 log of j omega the whole square, that is 20 log omega squared. Omega is omega C1, that is 5 radians. So 20 log 5 square is 28 decibels. Okay, so we got two magnitudes. And then for omega equal to omega C2 and omega H, we should go for change in slope formula. Okay, we have change in slope for omega C1 and omega C2. So omega C2 and omega H. Okay, so omega C2 we should take the change in slope this value, and omega H we should take the change in slope this value. Okay, so omega equal to omega C2, A equal to slope from omega C1 to C2 into log of omega C2 by C1 plus the previous gain. Okay, that is the formula. So slope from omega C1 to C2 is this one. Okay, 20 into log of omega C2 by C1. Omega C2 is nothing but 50. Okay, by C1 is nothing but 0.5. Sorry, 5. Okay, C2 is 50 and C1 is 5. So your 20 log of 50 by 5 plus previous gain, that is 28. So this is the formula. So you'll be getting 48 decibels. And then for omega equal to omega H, omega H is 100 radians per second. For that, if you calculate this A value, same formula, slope from omega C2 to omega H into log of omega H by omega C2 plus the previous gain. Previous gain is 48. The slope is here 0. Okay, so 0 into anything, it becomes 0 gain. So 0 into log of 100 by 50. Omega H is 100, omega C2 is 50, and plus previous gain. So this becomes 0 and we will be getting the 48. Okay, so for omega C2 and omega H, the gain value is 48. From this itself it is assigned, it is understood your slope will be 0. There won't be any slope between these two frequencies. Okay, that's all. So this is the gain calculations. After that we need to calculate, this is enough for the magnitude plot. Then for phase plot we need to go for phase angle calculation. Okay, so for Bode plot, the main aim is to draw the magnitude plot and phase plot. Magnitude plot is from magnitude, that is decibel, that is gain versus omega, and phase plot is phase angle versus omega. Okay, so here the phase angle calculation. So you can see here, this is your equation, transfer function, j omega squared. For j omega the angle is 90. If it is square means j omega to the power of n. Okay, n is 2 here, so 2 into 90. Okay, so you'll be getting 180. So 180 degree minus, and for this is nothing but a plus ib form. Okay, a is 1, b is 0.2 omega. So tan inverse of b by a, that is angle. B is 0.2 omega, a is 1 again. So 0.2 omega by 1 gives you 0.2 omega. So tan inverse of 0.2 omega and minus tan inverse of 0.02 omega. These two are why it is negative is because both are in denominator. Okay, so the angle should be negative. This is in the numerator, so angle should be positive. Okay, So 180 degree minus tan inverse of 0.2 omega minus tan inverse of 0.02 omega. This is the angle equation. So here for different values of omega, find out the angle. So if you go for this, it is also good, but not necessary. We have to calculate separately like this. Okay, directly you can go for angle calculation using this formula. So phi equal to 180 minus tan inverse of 0.2 omega minus 0.02 tan inverse of 0.02 omega. Simply omega equal to 0.5 you substitute. So 180 degree minus tan inverse of 0.2 into 0.5, and same way here 0.2 into 0.5. Okay. So if you calculate, you will be getting the angle in degrees. Okay. So it is 174, and same way for 1, we know 0.5, 5, 50 and 100 are the corner frequencies and omega L and omega H, but instead in between we have taken 1 and 10 additionally, because while drawing the phase plot is a smooth plot. Okay, it's a smooth curve. You should not use scale. So while drawing smooth curve, we need to have the points in nearby. Okay, then only we can able to draw a smooth plot, otherwise we cannot. So we are taking additional 110 omega values. Okay, so you have calculated these are the angles. Okay, then go for the drawing the graph. So this is your graph. So here you can see these are the omega values. So you can see this is the omega value. Okay, this is the omega value. So it's a logarithmic scale, it's a log omega scale. So you can see here, okay, it's a log omega scale. Okay, log omega scale. So here if you are going to take this can be, see, you can see here they have taken this is 0.1. Okay, 0.1. So that means this is 0.2, this is 0.3, and this is 0.4, this is 0.5. Okay, so this is value is 0.5. Okay, this value is, here you can see this is 0.5. Okay, 0.5, and then so this value should be 1. Okay, then this is 2, 3, 4, 5, 6, this is 5. Okay, and this will be 5. Then this will be 10. So according to logarithmic scale, 1 if you are going to take as 0.1 means next one will be 1, and next one will be 10, and the next one will be 100. Okay, so this 5 will be 50, the 2 will be 20. Okay, like that. This is 50, then this will be 100. Okay, like that. So we need to have 0.5, 1, 5, 10, 50, 100. These are the values we need to have. So you mark these values. Then for 0.5, the gain value is, you can see here, the gain value is for 0.5. Okay, for 0.5, okay, omega L equal to 0.5, the gain value is minus 12. For 5 it is 28. For 50 it is 48, and for 100 also 48. Okay, now you can see here how it is drawn. So for 0.5 it is, just now we have seen it is 12 decibels. So here they have marked. Okay, this is not seen clearly, but we can scale this, we can take the scale. Okay, so this is, if you are going to take it as 0, this is 0. Okay, if you are going to take 10, 20 like that, this is minus 10. Okay, minus 10, minus 20 like that, this is 0, and this will be plus 10, plus 20, okay, plus 20, and then here it is 30. Okay, then here it is 40, like that. 10, 10. Okay, we have taken 10 degree, okay, sorry, 10 decibels, okay. So 0, 10, 20, 30, 40, 50, like that. It's my this 0 now, it's minus 10, minus 20, like that. So minus 12 decibels. So minus 12, it is minus 12. Okay, so it is marked here. For 0.5 it is minus 12. Okay, then we know for 5 it is 28, so it is 20. So this is 28. Okay, this is 28. Okay, this is 28. And then here it is, this is 50 now. Okay, 50. Here it is 50. So this will be 48. Okay, this will be 48. So 48, 48 for 50 and 100, omega 50 for 48 and omega 100 also 48. So simply with the help of a scale, join all the points. Okay, so you'll be getting a graph like this. This is magnitude plot. Then for phase plot, this is k equal to 1 plot. Okay, so we have drawn the plot. Then phase plot. Phase plot, we have to mark the angles. You can also mark here, otherwise here. The angle, the values we have calculated is, you can see here it is 174. All are positive degrees, 30, 50, 106, 130, 168, 174, like that. So you can see here for 0.5 it is 174, 1 it is 168, 5 it is 130, 10 is 106, for 50 it is 50, 100, 30 degrees. Okay, so we are going to mark over here. So always the degrees, okay, if you are going to take positive degrees, always increases in this direction. Okay, so in this direction it increases like this. Okay, it increases in this direction. Now here it is 0 degree, means you can take any angles now. Okay, so you can also take 50, 100, 150, 200, like that also you can take. Okay, so you'll be getting a smooth curve, so it's small graph, that's all. Here they have taken each division equal to 20 degrees. Okay, so 20, 40, 60, 80, 100, 120, 140, 160, 180, like that they have taken. All are positive degrees. Okay, so it is increased in this way. Okay, so 20, 40. So the angle we have calculated is for 0.5 it is 176. So 180 here, 176 will be here. So they have marked here. Okay, then the angle, next angle is for 1 it is nearly 168. 1. Okay, this is 1 now, 168. Then for 5 it is minus 130. Okay, and then for 50 it is 50, and for 100 it is 30. Okay, they have marked all the angles. Okay, you know 20 is 40, means in between 5 divisions will be having 10 degrees. Okay, each this is 5 divisions equal to 20 degrees, means each division will be 4 degrees. Okay, so accordingly you have to measure the 30 degree, you have to place the point. Okay, so now you draw the smooth curve with a free hand. You have to draw, you should not use scale to draw this phase plot. Okay, and then the phase plot remains same. You'll though if you are going to calculate the k value, the phase plot, you won't be drawing the phase plot again. Only one phase plot will be there. Okay, but the gain plot will be maybe raised or reduced. That is, it goes up or down according to the value. Okay, the k value you are calculating, the gain crossover or phase crossover frequency provided in the problem. Okay, so here they provided you should calculate gain crossover frequency when it is 5 radians per second. Calculate k value. That is a question they are asking. So gain crossover frequency. What is gain crossover frequency? Gain crossover frequency is nothing but when the magnitude plot crosses 0 decibels. At that time the frequency is gain crossover frequency. Okay, but here for 0 decibel your frequency is not 5 radians. It is equal to some nearly this is 1 point something, 1.2 or something. It is not 5. Now you see for 5 radians what is the value? It is 28 decibels. You make this 28 decibels to 0. So what you have to do, if you want to make 28 decibels to 0 decibels, you have to subtract the 28 decibels. Okay, so 28 minus 28 only 0. Okay, so each and every point you have to shift downwards so that to get gain crossover frequency 5 radians. Okay, so you want to get gain crossover frequency 5 radians. Okay, your gain crossover frequency is omega gc. Okay, gain crossover frequency. Okay, it should be 5 radians, okay, per second. So for 5 radians it is 28 decibels. Okay, this is 28. Okay, so for that you are reducing 28 minus 28, it will become 0. So you can see here at 0 decibel you are having 5 radians. So the graph should be shifted downwards. Okay, so only I have drawn the graph like this. This is for this value. For this plot we have to find out the k value. So we'll be going for the k calculation. So the k calculation is, it is given, provided here. You can see here 28. Okay, 28 log k equal to minus 28. Here y means you are shifting 28 minus 28 is 0 decibel. So you are to get the gain crossover frequency 5 radians per second. You are shifting the plot 28 decibels downwards. So minus 28. Okay, so 20 log k equal to minus 28. Okay, so log k will be minus 28 by 20. Then k will be 10 to the power of minus 28 by 20. You will be getting 0.0398. Okay, this is the k value. So this, okay, you are plotting the graph and you are naming this k value is 0.0398. Okay, so this is what, that's all. We have drawn the graph. So we have calculated the k value also. So for the k value 0.0398. Okay, if you put the k value is 0.0398 over here, you will get the gain crossover frequency 5 radians per second for this problem. Okay, that is the information we are gathering from this plot. Okay, then for this problem there won't be any phase crossover frequency since there is no minus 180 degree. Okay, here all the angles are positive. So here in this problem you won't be getting any phase crossover frequency. Here they are not asked also, so no need to worry about that. Okay, so thank you.